All right. So again, good morning for those in the East. Good afternoon. Well, good morning for those in the West. Good afternoon for those in the East. Thank you for attending Snowflake Best Practices webinar. My name is Danny Bryant, and I am a solution architect at Snowflake. I'm going to hold all questions until the end of the presentation, but please ask any and all that you may have during this webinar via the Q&A box on the right-hand side of the slides, and I will get through as many as I possibly can once I'm done with the content. If you'd like to learn more about Snowflake, I encourage you to review the resource box where we've included links to upcoming webinars, new ebook content, and our popular virtual hands-on lab where you can try Snowflake for free in an instructor-led environment. Lastly, this webinar will be recorded, and we will send you a link for the recording on tomorrow. So thank you very much, and let's get started. So today we're going to spend the next probably 35, 45 minutes or so talking about Snowflake best practices. This particular presentation is going to cover global best practices and not specifically any particular workload that I won't be working on. So by the time we're done with this, you'll have a good understanding of several areas of best practices with Snowflake. All right, so again, my name is Danny Bryant, and and I'm a solution architect for Snowflake. I've had some experience in the Oracle space before as an Oracle ACE director. I tweet, I blog, I speak. I've presented at the Snowflake Summit last summer, and also if you happen to be in New York, you may have seen me at the Summit World Tour earlier this year, and I've done a number of sessions at Open World. And then I also do some leadership roles in some technology groups here in Atlanta. So I really enjoy the space and try to contribute as much as possible. Let's look at our agenda. So through this presentation, we're going to look at 5 different areas: warehouse management, cost management, network security, user authentication, and role management. And so through these topics, you'll walk away with a really good understanding of how you can best optimize your Snowflake environment and configure for your specific areas of interest. So let's get started with virtual warehouse management. So the virtual warehouse management, we will cover things such as right sizing, which are important because we don't want our customers using warehouses that are either size too small or too large. We'll talk about scaling up versus scaling out and the advantages of those and how those impact your workloads, and then some best practices on when you should think about automating your suspend and resume, sizing, and then multi-cluster scale out. And so why do we look at these? When we have our warehouses, most of the time we want something to run faster because we have SLAs that we need to meet. We have multiple use cases, we've got data loads and transformations, and we don't want contention. And then we want to be able to understand how that's being impacted from a cost perspective, how we're able to utilize various workloads and warehouses in combination so that all of our users are able to get the best out of Snowflake without impacting other business units. And so we've done a great thing here. We like to size our warehouses like t-shirts. So you can go from an extra small, which comes with basically one node. And so from a billing perspective, you see here, it's like a credit per hour. And this is the default when you create your warehouses through programmatically. If you notice midway through where we have an extra large, which comes with 16 nodes, you then find that that's the default if you use our web UI. So we go through these. As you can see, each one of those basically grows or doubles the size of servers, which when we think about this is going to also allow us to, in essence, double our ability to perform on various workloads. So in this particular diagram, when we talk about right sizing, one of our things that we like to look at is start somewhere in the middle and then decide whether or not that particular process is running in a reasonable amount of time. And so the chart here really shows that as I go up in size, the time it takes for a particular workload to run decreases. We like to say it's linear. It gets to a point where it It's not quite linear, where we kind of see going from an extra large to a 2XL. We don't really get a linear decrease in size, but obviously each workload pattern is going to determine whether or not you continuously get linear results. But at some point, you will start seeing where that doesn't always happen. So again, from a best practice is to understand, one, what that workload is, start somewhere in the middle with maybe a large or a medium-sized warehouse, run that workload, get feedback from your customers or from your business units, and then begin to adjust those warehouses to meet the needs of the customer, to where now you are not using a 4XL to do a copy command and a small to do some complex query. You're actually able to apply the right size warehouse to the right size workload. So the next thing we talk about is the scaling up versus out, right? So scaling up, what does scaling up mean? Scaling up means that we're going to increase the number of nodes that we are going to dedicate to the query performance. So each of our nodes comes with 8 threads. So parallelly running 8 threads means that as I go up the scale for performance, I'm doubling the number of nodes. So an extra small is 1 node with 8 threads. When we go to a small, we actually get 2 nodes and 16 threads, and so on and so forth, up to the 4XL, where we end up with 128 nodes times 8, which I believe is 1,024, parallel processes can be run. And so this becomes important when you're trying to do things like copying files and loading them from S3 or from Azure Blob or GCP storage into Snowflake. You'll want to be able to take those files, and if you have the appropriate number of files, you can then parallelly load all of them, depending upon how you want to scale up for that performance. When we talk about scaling out, we're talking about concurrency. And so when we look at that, concurrency means how many different things can I run at the same time. So there's a game to play with how you are multi-clustering your warehouses for concurrency versus scaling them up so that you can get better performance. And obviously the combination of those two gets you to where you have the appropriate level of performance for any of the workloads that you may be running. And I just kind of highlighted a couple of things on here. If you see the XL that's squared off in the block in 16 in column 1, but you also can have 16 running at a medium if you stitch 4 of them together. You will get different results based upon what your goal is. So if you want performance, you're going to scale up. If you want concurrency, you will scale out. Even though you're looking at the same number of nodes, the way they are positioned for applying to your workload will give you a different result based upon what you're trying to do. So it's important to understand that differentiation between those two types of things. And then finally, we look into as we talked about, automating your suspend and resume. What we talk about here is, when we build a warehouse or create a warehouse, Snowflake has the ability to set that warehouse, or you as a user have the ability to set that warehouse so that it suspends after a certain amount of time that no query is being executed upon that. Well, why is that important? Because you pay for warehouse usage. And so no one wants to pay for warehouse usage when they aren't using it. So you have the ability to set an auto suspend on that warehouse. So once a query stops running or a workload stops, the warehouse it may sit for a little while, a minute, 5, 10, whatever you determine as your threshold before you want to put that back into or suspend that warehouse. You can leave that warehouse going. When it's suspended, you are no longer billed for the utilization of that warehouse. The auto resume means that if you have a suspended warehouse and you issue a query that is using the warehouse, it will spin back up automatically, and it will then execute your query. This happens within milliseconds, so we're not talking about executing a query and then waiting 2 or 3 minutes for a warehouse to resume, and then you get your results. And so it's so fast that you won't even recognize that the warehouse is down unless you are at a 4XL with 10 warehouses clustered together. It may take a little time to spin up 1,280 nodes, but I think we all can understand that's a huge workload. We talk about programmatically suspending and resuming because certain workloads, in particular copying files from your blob storage into or external storage into Snowflake, have a known start and a known end. So from a programmatic perspective, you can, through Python or through whatever programming language you feel comfortable with interfacing with Snowflake, you can actually start a warehouse, execute your commands, and at the end of that process, immediately suspend the warehouse so as you get the minimum amount of time necessary for a warehouse to be running. And therefore, again, going back from a cost perspective is not having that idle time where we know that nothing is happening. Now, I'll step back a bit because sometimes we get into the discussion around caching within our warehouses. And for certain activities, such as copying files, caching is not important. So we don't really need to keep that warehouse running. But if we're executing queries where we're getting result sets back, if the warehouse continues to run, you can take advantage of, with future queries, can take advantage of result sets being cached, which do not cost anything because we're no longer using the warehouse to execute. We're reading that data set from cache and delivering it back. So there again is some opportunity for our architects, our data engineers, or those individuals that are going to be setting up these warehouses to, if you've got BI tools that are running queries over and over and over again, you may want to extend that auto suspend time for 30 minutes so that as new queries come in, that cache is still sitting there, that cache is current, and you're getting almost instantaneous results back because we're no longer having to use the warehouse to go to disk to find these micro partitions, pull this data back and deliver it. It's all sitting on the local cache at the warehouse, thus providing a faster performance and also not causing you to have to spend cycles on your warehouse. So the automation of the suspend and resume, again, goes into looking at your workloads, trying to determine and figure out what is the best approach to queries versus other activities like copying. I'll just kind of stick on copying because it's a simple concept to understand, but versus the copy into suite that allows you to just move data from an external source into Snowflake, and you know when those start and stop, and so you can automate that process and not rely on Snowflake to, at some point that you've configured, let a warehouse continue to run without any activity going on it, thus, again, reaching back and talking about savings and talking about how you provide the best performance to your business units. All right. So that gives us a great segue into cost management. And what we're going to talk about really here is how do we look at the different components and objects within Snowflake that have a cost associated with them. And so here we go. Resources that incur costs. So compute, which is our warehouses. So when we talk about virtual warehouses, we don't want to confuse that with the actual physical construct of what we think a data warehouse is. Virtual warehousing is the compute process that is being applied to whatever workload you're having. And we have tools that will allow you to view the usage, and also, if you see resource monitors, which we'll touch on, allow you to set up limitations and notifications on warehouses so that you have control over how many of your credits are being used for specific warehouse workloads. Storage is another one of the cost impacts. There is a cost to store your data in Snowflake, and we'll look at some of the things that give you value out of that, and understanding how the cost associates with the different object types, and some of the key features such as time travel and fail-safe. And again, we always try to give you ability to view how that's being used. And then finally, services. non-warehouse compute. Services typically mean things like Snowpipe, which is an automated tool which uses a Snowflake managed warehouse or warehouses. So you don't really have control over those. However, there is a cost associated that would be applied to you. We won't get into how much that is in this session. We'll leave that for you to discuss with sales guys and whatnot, but we'll talk about the technical aspects of those as we move forward. Okay, so we look at this, kind of lays out the different pieces. We talked about virtual warehouses. When we talk about the storage layer, as you can see, those are the lighter blue colored boxes. The service costs, auto ingesting, automatic clustering for optimization of your data warehouse. So if you've got if you want to, we don't do partitioning, but we do cluster. And so you can build a table and have cluster keys that allow you to organize the data in a way that will give you the best performance on a query. So if you've got something that's dealing with dates, then you can actually create a cluster key that pushes date up to the top, and the micro partitions that make up that table are organized by date. And we recommend no more than 3 from a cluster key, and we'll talk a little bit about that later, but you can string along as many, and Snowflake will try to organize that data to make, as you layer through those, the optimal query performance based upon your cluster keys. So kind of think about that in align with partitions. I think about that when I look at an Oracle partition, go, okay, but like for Snowflake, we use cluster keys to give a very similar type of result. And then there are pass-through costs. Like if you're gonna egress or copy files out of one region to another, there's a cost associated. We don't throw anything on top of that. We just pass that along through to you. All right, so our resource monitors, they allow you to define target thresholds for virtual warehouse compute usage, and they trigger some event when that threshold is reached. It can be an email, it can be a lockdown of that warehouse. So it's very flexible and allows for granular cost governance for large organizations that may require breakdowns by team or business unit, but give you that account level control. So resource monitors can leverage tiered triggers. 75% do something, 90% do something else, 100%, maybe we'll say, oh, if they reach 100%, we'll let them go to 102% of the credit quota before turning the warehouse off. So the recommendation that we have for customers is to utilize your resource monitors to put some guardrails around your compute cost. This allows, for example, somebody may execute a query that just goes crazy. It's going to burn credits. If you put resource monitoring in place, that query will ultimately be stopped, whether because you've been notified of a certain threshold or you've set the resource monitor to actually kill the warehouse when a certain credit quota has been reached. And so if we look at the diagram here, you can see how we've got credit quotas, especially, so resource monitor 1 is set for the entire account. So you can say, when I log into Snowflake, and that's what we consider our account level, then we can note this account can only max out at using 5,000 credits. It doesn't matter what warehouse is being run. Our resource monitor 2 is assigned to a specific warehouse and says this specific warehouse can only consume 1,000 credits. Once that happens, depending upon what you've decided to do at that point, send out a notification, pause the warehouse. Once that credit quota is reached, whatever workloads are running on warehouse 3 that has a resource monitor to it will stop, because the warehouse will stop. And then finally, you can combine warehouses and give them a total number of credits. In the case that we have resource monitor 3 is looking at 2 separate warehouses. And again, warehouses being the virtual warehouse, the compute power, not the physical tables and other objects. This is the computing process. And so we have that. And a good bullet point here is enable notification, account admin role, and you must have an email address set so that we can actually send you the email. This is not a feature within Snowflake where you can actually write code to use an emailer, but from this perspective, from notification, if we have an email address, then the resource monitor can send an email out to a specific user, letting them know that these particular thresholds have been met. Okay, so let's move into storage. When we look at storage, we've got standard operations queries. We've got time travel. So time travel allows us to select data in the past. We have a retention policy that is set by user of 0 to 90 days, which will impact storage costs. And then we have fail-safe, which is, as you can see, there's transient tables and permanent tables, which we'll look at in a second, that also have some storage related to it. The fail-safe is a feature from Snowflake that if you exceed whatever your time travel retention is, we will still retain an extra 7 days, and you can work with our support team to recover that data. But when you're building out your environments, you'll want to also make sure that as you are creating tables and setting up time travel, is that you apply those to the appropriate tables when you are when you're building these out. Time travel is important for undrop, which means that somebody dropped a table. If I have time travel set for a number of days, I can just undrop that table back to a time prior to the drop. So it's kind of like putting something in your trash, and then you're able to restore it back from when it was last dumped into the trash. Key is that you have to have time travel established on that particular table for that to happen. If you have it set to 0, as soon as you drop it, it's gone. So recommendation, 2 things. 1, think about time travel, but 2, also understand that there's a storage cost related to time travel, and that time travel may not necessarily be required for all of the tables or objects you have in your database. So let's look a little bit further into this. So our table types, temporary tables, tied to an individual session and last only for the duration of that session. So maybe you want to do that for some ETL processing, that once you're loading some temporary tables, you've got to do some ETL work within those tables before you move them. So maybe a staging area before you move them into a permanent table where now you're going to have your BI analytics tools now consume that data and provide it out to your business units or customers. Time travel is available on this. Fail-safe, however, is not. So we're not gonna, from the last slide, we aren't gonna retain 7 days worth of temporary table for you to go back and go, oops, something happened. Let me go get what that looks like up to 7 days ago. Our transient table, specifically designed for transitory data that needs to be maintained beyond the session. So now we're saying this is a step up from temporary. So transient says, I want to keep these. I don't care about fail-safe, but I don't want them to disappear when I close my session out. Again, time travel is available on these. And then the permanent ones, which are designed for the highest level of protection. Fail-safe is available. Time travel is available, which means that I can say, retain this data, no matter how many changes are made to the tables that are permanent, I can go back and look at that table at any state between 0 and however far back I have established time travel. We can write a query that says, show this table as of a certain timestamp, and you will get that result set back. This is because of how we have our micro partitions structured in our storage layer that basically said that it's immutable. So we don't get rid of them. We mark them as unavailable or deleted, and we rewrite new micro partitions every time. So we have the ability to go back and look at what a micro partition looked like at a certain time if you have time travel turned on, which is also why we're able to do things like zero copy clone, which just points to a specific set of metadata or micropartitions at the time that you did the clone. And then also we have the fail-safe, which is an extra set of 7 days. And then our ability to do undrop, where we can go back and say, oh, these are dropped as of this time. Let's go back and look at the micropartitions that we have said are no longer available, but this is what it looked like, and we can bring those back. All of these require some level of storage. So we want to be cognizant of the fact that when we do these, we're addressing the appropriate table, the appropriate amount of time travel, the appropriate amount of churn that happens in tables as it relates to fail-safe, so that we can do a good job of managing the expectation from a cost perspective. And also, again, what is the right type of object to store tables for the utilization of our business units. Right. So we did kind of a little bit more into time travel. High churn detected in time travel. What does that mean? Well, if I continue to make a lot of updates to a table, that's considered churn. What does that mean from a storage perspective? Is we are continuing to write micropartitions every time you make that change, which means from a time travel perspective, your storage will go up because we're keeping a bunch of different copies of the way the table has been organized through either inserts, deletes, merges, updates, so on and so forth. So what do? Reduce the retention period if data can be regenerated. So if you've got an ETL process that you can run and it's done in a couple of minutes, then maybe you don't need to have a lot of time travel on that particular table because you can just go back and regenerate it. If it's a derived table from other tables that you have the queries to build, maybe you don't have a lot of time travel on that final table. Maybe that time travel is better positioned on the base tables that you're using to build this additional data set from. And then also using periodic zero copy cloning says that you can create a zero copy clone, which points to a set of micropartitions as of the date of the clone, and you can go back and view that. So you can reduce your time travel because you've got a copy that doesn't cost anything to you because we're pointing to existing data, and you can go and refer back to that particular clone of your table, database, schema, what have you, at a certain time to minimize the amount of data that you're storing for time travel purposes. And so again, we have our area of focus, dimensional tables, persistent staging, and materialized relationships. So these are the areas where you want to focus in on time travel storage, because those are the ones that consume the largest amount of storage when we talk about our data warehouse. So again, fail safe. That's the 7 days of data that support can help. So it's really only relevant if that data is significant long-term value to your company. If you don't need it, then there's, we really don't want to invest a lot of time in this process. So to eliminate fail-safe storage, you need to use a temporary or a transient table because fail-safe doesn't apply to those. Remember, your temporary ends at the session level. Transient sticks around but doesn't use fail-safe, therefore, again, reducing the total storage footprint and still allowing you to have access to some time travel on those tables. So the question becomes whether a table should be temporary or transient. In situations where a table is not shared across sessions and is used to store short-lived data sets, then a temporary table is most suitable. A transient table would be a better choice if you do need to share it across sessions, such as staging data that's populated by Snowflake, then transformed by something else, and then propagated through to an initial, to a final landing place in a different session. So session persistence becomes important in this particular scenario. And so we want to make sure, again, that we're utilizing the proper table type to effectively take advantage of the features from the data protection services that are embedded within the Snowflake data warehouse. All right, on to network security. So this is a relatively short section. We're going to talk a little bit about the different ways that we're going to keep people either from accessing your Snowflake environment. All right, so we have a layered approach to our network security. There's the authentication piece that says, hey, can I actually connect? Then there's the user, and then there's object authorization that goes into our uses of roles and schemas. And then finally, we encrypt everything in flight, on disk. So all of these layers of security are important as it relates to making sure that you're comfortable with utilizing Snowflake for your particular data, your data process. All right, so what are these areas? Network security policies and AWS Private Link. So the considerations, you can IP whitelist or blacklist. And then when we talk about AWS Private Link, we are in effect isolating Snowflake to your existing AWS resources via private link. Therefore, you cannot just go up to any computer, connect to the internet, punch in your account or your URL and get access to it. You have to go through private link, which suggests that you're inside an AWS environment already and that all the traffic stays within AWS and does not go out to the public internet. And so these are managed in our UI. You can also programmatically set these up. You have to either be account admin or security admin to do this. And in order to implement the policies from the GUI, you can navigate to the appropriate tab, and then you can enter in your IP address ranges. I would suggest uses ranges versus a list whenever you can, so that it's easier to manage. And blocked IPs are enforced first. And so therefore you want to make sure that you don't block an IP address that you ultimately want to allow, because the blocked IP will override that. And as you can see on the screen, only one policy can be active at a time. And this one's named employees. And we're saying we're going to allow everybody in this 192.168.1 class C range to be okay. But we want to block this particular .99 IP from accessing. And so, and then the SQL, which I mentioned earlier, you can do this programmatically. When we have windows in our GUI that allow you to set up stuff, there's always the ability to click Show SQL, so you can see exactly what the SQL statement is going to be run. Feel free to copy that out, paste that into your application or your tool, if that's how you want to deploy this, and it runs just fine. So that's just an additional plus. And so again, being aware of that, test that plan. You want to make sure that your admin who may be working from some other location isn't stuck in the block or in what's been blocked, and that he's been allowed to get in. So making sure that the policy configuration is appropriate to prevent access. And this means when I try to punch it, when I try to just go to the website, the URL for my Snowflake account, I will not be allowed in. The next piece we'll get into talks about the access from within Private Link. So what does Private Link do? It allows AWS resources to communicate to each other without going across the public network. So if you have your own AWS account and you've got your own VPC, then you can say, hey, I want to use Private Link between my VPC and the Snowflake VPC, so that if I have resources within my account, they don't go out to the public internet and then come back in and access Snowflake. They go through a VPC endpoint, which is established by reaching out to support at Snowflake. And then there's a lot of documentation on that talks about how you set all that up. But once that's done and you get those endpoints, you can then isolate your environment so that there's no public internet access. It's available with the Business Critical Edition or higher, so that becomes important. And then also some other notes around your networking. When that URL will change, as you can see in here, the Snowflake host name becomes something.region.private link, which if you don't have Private Link, that's not part of it. So a lot of things may have to change if you choose to implement Private Link as part of your security, your network security policy. So the next piece is we've been able to connect, and we're presented with a login screen. So how do we manage our user authentication? MFA, or multi-factor authentication. We have federated authentication, SSO, and then OAuth. And so these are the primary mechanisms by which customers or business units or users can now log into Snowflake once they've made it to the login screen. So multi-factor, we're not going to talk about the intricacies, but it's powered by Duo. It's managed by Snowflake. So after a user successfully provides login credentials, you will get a notification to your Duo mobile app, which you will then have to say, yep, that was me. And once that authentication has been accepted, you're then able to access the Snowflake GUI. This also applies to programmatic access if you set up MFA for, say, a Python script to connect to Snowflake. When that script runs, somebody who has set up MFA for the user that's trying to connect is going to have to authenticate that using the Duo mobile app. You self-enroll, and we also recommend that you set up MFA for account admin at a minimum, security admin as well, so that or somebody has to do a second level of authentication when these power roles are being used in Snowflake. And so again, I mentioned it: Python, SnowSQL, JDBC, ODBC. All of these can use Duo generated passcodes when they try to connect. So federated or SSO. Any SAML2 or most SAML2 compliant providers, Google, Azure, OneLogin, Ping, we have native support for Okta and Microsoft ADFS. And so there's documentation that allows you to set it up. Utilizing SSO with MFA is a powerful combination in terms of being able to understand it and make sure that only valid users are logging into your Snowflake environment. And then finally, we look at OAuth. We have support for tools such as Tableau and custom client applications. And while there's no support for MFA and OAuth, we do support Private Link, as we mentioned earlier, that allows AWS applications to have a potential to use OAuth all within an AWS infrastructure. So if you want your applications to have that elevated level of Snowflake, you need to reach out to support because currently the default role for a user to use OAuth is public, and so the account admin and security admins are normally blocked, but we can work with you from a Snowflake support perspective to enable those higher level role accounts access using OAuth. Then let's get into role management, which is really kind of our last section. So we've talked about how users can authenticate. We've talked about network security. How do I just prevent somebody from accessing the URL? We've done some things with our cost management and looking at resource monitoring. How do we make sure that we don't have any overruns in credit usage, runaway queries causing us to burn all our credits? And then we've also looked at high level from a perspective of our data warehouse, our virtual data warehouse compute resources, and what we need to consider and take into account as we deploy these particular warehouses and the workloads that are going to be run on them. And so finally, we look into role management, which is the final level of kind of where we talk about security and understanding once we're into Snowflake now, how the application of roles gives us access to the objects that we have within our various Snowflake databases, schemas, etc. So when we look at these, who are our administrators? Who are our developers? Who are end users? Do we have service accounts that are connecting to Snowflake and executing specific tasks? How do we address allowing those users with specific roles to be able to do their jobs without having elevated access or not enough access? And we use roles to do this. In a lot of environments, you'll see when, and I'll kind of go back on my Oracle experience. When you create a user in Oracle, there's a schema called that same user, and then all the objects within that are owned by that user / schema name. When we look at Snowflake, however, a user doesn't own any objects. The roles own objects, and you grant the roles to a particular user to give them access to that to those objects. So there's a little differentiation when we think about role management in our different database platforms, but understanding at the end of the day, for Snowflake, the role is the owner of the object, and the only way a user can have access to an object and execute against that object is to have the role that has those privileges. And so let's look at a couple of those. So we have system-defined roles. These are the ones that come with Snowflake just because you have Snowflake. There's an account admin. And what is that? It owns the account. It operates at account level stuff, billing, stopping and running. So you can do anything with the account admin. That's the super role. Anything that you want to do basically within Snowflake, if you have account admin, you have the ability to kind of go in and do some stuff. Security admin. It's the role, again, to manage users, grants, and object access. System admin is for objects. So we're looking at system admin. This is what I'm going to use to create warehouses and tables. And then public, it's kind of like this role that everybody gets and every user has access to it. Sometimes what we see in the public is people will put in file format definitions, maybe some stored procedures that everybody needs to be able to use so that it's not tied to a particular role. Some organizations will create a separate kind of operational role and put a lot of those types of utilitarian tools in there and grant everybody access to that role so that it falls outside of a particular custom role that be made for a specific department or business unit or function. So let's dive in a little bit more. So, the above slide, the slide that we see here, assumes requirements for a read-only role. And we can see that where we have this junior analyst here that all we want to do is give them the ability to select. So we also have the analyst lead, which needs to do what? Select, insert, update, delete, alter user, all still in these different schemas. So there's a working area and there's also a main. So users with a combination of access to objects, the analyst team leads needs full access to the working schema. In addition, needs read access to the main schema, while the junior analyst only needs to be able to read from the main schema. So both of these share access to a virtual warehouse, as we can see is indicated at the top, where they both have the role has the usage privilege for the warehouse. So again, the role can use the warehouse. Anybody that's been granted an analyst role or a junior analyst role can use that warehouse. Right? What's the solution to that? Well, let's look at inheritance. So role inheritance allows us to separate out the team lead and the junior analyst and inherit specific privileges. So our analyst can use the warehouse and our analyst can select from the appropriate table. Then what we do is we say, and in this particular scenario, we then let our analyst, our team lead analyst, inherit what the junior analyst has, and then add in the usage to the ability to query from the working area. So instead of creating several different usage and role grants across different users, we can apply the minimum role privilege to a specific role and then have other roles inherit those privileges, and then you can add on the extras so that we're at a point where we're not recreating the same privileges over and over and over again. We're just taking privileges that we've already created and we're able to allow them to inherit, allow others to inherit those privileges that we want, and then we can add additional ones as necessary. So let's go to the next slide. All right, so we're about to close out, and then we'll open up for the next few minutes with Q&A. But finally, we talk about other considerations when we're looking at best practices. Naming conventions, be consistent. That's really the best one, is don't have a bunch of different naming conventions. Try to set up and establish a consistent naming convention, because that actually allows, from a programmatic perspective, for you to build things dynamically because they follow a common pattern. Thinking about future grants. Future grants allows defining a role with an initial set of privileges on an object, of a certain type within the schema. And so when you do that, instead of having to apply that grant over and over and over again, you allow the future grant to take care of that for you. We have viewing granted roles and privileges. So we've got, as we've mentioned, or I've mentioned throughout the presentation, is you've got the ability to view certain components or aspects of your environment. In this case, to show grants to user, show grants to role, show grants to role, and then your information schema. So all of these give you the ability to see what those grants look like, what your environment is looking like, and how you've been able to structure your privileges across your account, and either come up with a different approach or at least have an understanding of what that approach is. And then finally, what we have is the managed access schema. So it centralizes grant management to the schema, from the schema owner or role with the managed grants. this is the ability to give a particular role the ability to handle grants and takes it away from the actual object owner. So you may have an organization that somebody builds and it creates a database object. The manage grants role will allow whoever has access to that role to be able to take care of who gets access to those other objects. And so, excuse me. So with that being said, in our final slide here before we go into Q&A, just wanted to thank everybody for hanging around with me for the last 45 minutes. And then I see here as I look at our QA that we've got a number of questions coming in. And so give me a few seconds to pick out some cool ones to answer. And I will read them out and answer those questions for the next few minutes. So let's see. So we have a question here that says, what specific best practices exist for customers to provide reporting solution in multi-tenant environments of their own? Do you recommend separate databases, tables, and accounts? So if I understand this correctly, what we want to do is, when we look at Snowflake, Snowflake is the databases are within a single account. So you can have multiple customers have their own database, or if you have a need for some type of billing differentiator, you can have multiple accounts. And I put the account as the URL and then the user. So you can separate those between the two and say, I can either have one account with multiple databases in it for my different customers to have access to. Those databases through roles can be secured, so customers won't be able to see other databases in there, more like a kind of a shared architecture or multi-tenant architecture, or you can do separate accounts. Same account allows for more sharing of data. Separate accounts, we look into other tools like data sharing and some other things that we didn't go to allow if there's a need for customers to go to. So the approach would be you've got to decide whether or not the features within the same account outweigh having a separate account, but both of those are appropriate ways to handle that. Let's see. All right, so we've got one that says, how is time travel different from zero footprint client? Is latter the cost effective? So if it's zero footprint, what we have is zero copy clone, and then time travel are the two comparisons I made in the presentation. And so from a cost perspective, if you make a zero copy clone, that doesn't cost you anything because we're pointing to existing micropartitions. Time travel, however, builds micropartitions as you change the data, and so from a cost perspective, a zero copy clone doesn't cost you anything. Time travel, if you set that out to 90 days, you will have incremental cost because you've got you're retaining all the different permutations of those micropartitions that result in what that table looks like. So zero copy clone, no cost because you're pointing to existing stuff. Time travel does have a cost associated with it because you are retaining more data in your account. Let's see. Can you set security at a more granular level than a virtual warehouse, i.e. a user can only view a subset of tables in the virtual warehouse? Okay, so I think we need to make sure that we're clear on this one, is our virtual warehouse is compute. It is not the actual, what we think of as a data warehouse where the data warehouse has tables and schemas in them. And so from that perspective, we can control who has usage on the warehouse, so who can actually use that warehouse to query the data. A user can only view a subset of tables. Well, yes, we can set up roles within our database or account that allows a user to only see certain sets of tables. But there is a differentiation between the virtual warehouse, which has been defined as the compute, and the actual tables, which are storage in a Snowflake environment. Okay. Let's see. Here's one. What are the possibilities of getting Python in UDFs and stored procedures? This is limiting our use of Snowflake. So we have heard there have been requests to do this. I won't go into roadmap stuff, but if you go to our website, and this is by Clark Bishop, if we go to our community website, there's an ideas section that when people put those in, they get put into our system for ideas, and that helps us figure out what the demand is for those types of things. So so at this point, we've heard the request for that. Right now, our stored props are JavaScript, but yes, we've heard that request, and I would suggest going there in order to add your name to the list of requesters for that particular feature. Could you repeat when transient tables are useful versus permanent or temporary tables? Yes. So transient tables are tables that will that stick around. And let me see if I go back to the proper slide here. We don't want to do it that way. Well, anyway, so we'll excuse me. Let's see here. Nope, up there. Let's find our transient tables. Let's look at that one. Okay, all right. So temporary tables are at a session level. So when we talk about this thing is when we log out, any table that we've created as temporary goes away. Transient doesn't have failsafe, but it does last beyond your session. And in your temporary tables have time travel and failsafe, and those are the ones that are designed for what needs the highest level of data protection, because we have both time travel and we have failsafe applied to those. So I hope that answers that question for you. Let's see here. So would you recommend MFA for sysadmin? Those fellows can create and run warehouses so they can bring additional costs. So I would recommend MFA for any of our super accounts, so that somebody, and for MFA, it doesn't necessarily mean that they can't run warehouses, but MFA means that they can't log, that we're adding a layer of protection from actually logging in. And so I would recommend MFA for any of our super accounts, so that somebody doesn't inadvertently get hold of an account that has access to the sysadmin, or has that default role set at sysadmin, and there's no secondary, oh yes, I meant to do that, or somebody's trying to log in with a user that has that's default sysadmin role, and not have a second layer of protection against that. Let's see, got time for about 2 more questions. All right, so this one here's like, can you block ranges of IPs as well? So the answer to that is yes. You can. You do not have to list individual IP addresses. You can use the CIDR, CIDR notation. So kind of like whatever the IP address is /2416, whatever that range is. Yes, you can block IP address ranges as well. I do want to go back and make sure that we understand that the blocked addresses will take precedence over the allowed addresses. So make sure that when you do a range, that you don't inadvertently include some addresses that you actually want to have access to. And then let's, because this last one here, all right, let's see here. When resizing a warehouse that is currently running a query, does Snowflake create a concurrent warehouse at the new warehouse size with the same warehouse name? Does resizing affect caching? So when resizing a warehouse that's currently running, whatever the existing query is that's running has to complete before the new warehouse will take on the next query. And there's resizing affect caching. So when you resize and you bring in new things, yes, you'll affect your caching in that perspective, because you're actually like kind of reprovisioning a set of warehouses so the affinity that is there from that queries don't span over, or rarely span over nodes. So I hope that answers that. That's a pretty good one. And so finally, I'll do one last one. Are there considerations for determining when you need to scale out? So again, when we talked about scaling, scaling out is for concurrency. And so as you scale out, you will experience thresholds to where you start getting, reports that, oh, my queries are running slow, I'm getting a lot of queuing, and so on and so forth. So the consideration to determine when you need to scale out is you have to look at, are you having multiple, it's concurrency. So are you having multiple concurrent users or concurrent processes running that exceed what your current warehouse size is? And so you would want to scale out so that you aren't queuing up resources because you have multiple requests for particular resources. So the scale up, I'm going for performance, I need it to run faster. Scale out is I need more of these things to run at the same time. And so, yeah, you would say if you're scaling out, you're looking at concurrency versus looking at this performance. All right. So I think that's going to be it for the questions. We've got the questions. If you have some others that we'll be able to have people reach out to you to help you get a better understanding of some of the best practices and some of the nuances and details behind them. And so at this point, I'd like to say thank you very much for attending the Best Practices Warehouse. Again, my name is Danny Bryant, and I am a solution architect at Snowflake. So thank you very much.